Hi engineering Janta, I am Vaibhav Shukla and today I welcome you all to the episode 5 of Statistics for Data Science. So if I am visible and audible to you people, go ahead and tell me in the chat section. Tell me in the chat section if I am visible and audible to you. Great. First, just confirm whether I am visible or audible. You can type out a yes to tell me for the same. Great. Great. Thank you guys. Thank you. So let's start today's class. पढ़ना शुरू करते हैं, ठीक है? And okay, great guys, I got you. Fine. Okay, Sumant. So these guys are regular students. Good evening guys. Fine. So I'll straight away jump in to teaching today and आज की class बहुत हल्की है. Fine, it is a very small class, so not a very big deal for you people. Easy one. But let's start the discussion from where we left yesterday. Fine. So random variables for what we were discussing, isn't it? यही discuss कर रहे थे कल हम. Good evening. Now, in these random variables, I had shown you two primary things. Fine. One was discrete random variables and the other were continuous random variables. Fine. So for these two types, I had asked you to do the homework and tell me about these two. So if you guys have done some homework, tell me what is the difference between these two. So first of all, tell me what is discrete random variable. Fine. Type it out. I'm giving you a minute. Type it out in the live chat section and I'll see it. So tell me what exactly is this, and then I'll deep dive into discrete random variables and I'll explain you. It is similar to the concept that we had studied about discrete variables when we were talking about quantitative variables. Fine. It is similar to that. ज़्यादा कुछ change नहीं है, same ही है almost. You go ahead, tell me in the chat section and let's see whether you guys have done your homework or not. I'm waiting for your responses. Go ahead, tell the basic definition or whatever you've learnt about discrete random variables. जो भी सीखा कल. Okay, discrete random variable is the countable number which will be generated at random. Perfect. बिल्कुल सही definition है demo channel. ठीक है, it is absolutely perfect. So the point is, जब भी कोई random event हो, fine, and in that random event you can calculate the outputs or you can get the outputs to store discretely, then it is discrete random variable. For example, rolling of a dice. Fine. Rolling of a dice is an example where what kind of outputs you get. For example, if you've rolled one dice, what do you get? 1 or 6 or 3 or 2, such numbers you get, or 5 or 4. These are the numbers that you're going to get, but randomly out of any of these numbers, one would appear. So, hi, good evening Vaibhav. Sumant has written a discrete random variable is a type of random variable that can only take on a countable number of distinct values. Perfect. But these distinct values that are coming up, Sumant, are being generated from a random experiment because this is random variable, no? So, those variables which hold the values which are generated by any random experiment where the probability or the chances of occurrence are random at that point of time, you have random variables. So discrete random variable, you guys have done homework. I'm happy. That's great to see. Now coming to the continuous random variables, if I talk about them, the only difference is here those random experiments which give continuous values. For example, consider in your city there is some concert tomorrow, fine, and in that concert the weight of the people who are coming, fine, that weight can be 162.5, that can be 85.5, that can be my weight which is 350.5, fine. So such weights can appear, fine. So in this case, these values that are coming in front of you are actually continuous random values, fine. These are generated by continuous experiment, these are generated by random experiments but are continuous numbers. Now, number generated in between the range, no, that's not right, ये correct नहीं है बात, ये range में generate नहीं हो रहे हैं, these are decimal numbers. Here only whole numbers can come, fine, such whole numbers, whatever random generation of experiment gives you is a whole number that can be held here, fine. But here when you have random variables, here you have continuity in numbers, which means they are decimal numbers or fraction numbers. In the concept of mathematics, these are called continuous numbers as well, fine. So I guess that much is clear. This is pretty easy, no rocket science, easy peasy job. I hope that much is clear. Clear to everybody? फटाफट बता दो. Tell me in the chat section, is it clear to everybody what exactly random variable is, what exactly discrete random variable is, what exactly continuous random variable is? Is it clear? Tell me in the chat section. Okay. Time exam, very good. Sumant, very good. Time is example for the continuous random variable which is continuous, but now let me tell you that time that you're saying, for example, you're saying that any time in tomorrow afternoon from 1 to 3 p.m. at any point of given time and in that particular frame, you come and talk to me, fine. So in that case, from 1 p.m. to 3 p.m. you can have multiple values, you can have 115, fine. This is particularly a continuous random variable, however, not exactly, fine. In the longer run, you will understand that these, here we are talking about numerical data, but fine, for now, yes, you can consider, fine. So chalte hain aage, let's go forward and let's understand about today's topic, which is histograms, fine. बहुत ही मजेदार चीज है. You have been acquainted with this earlier as well. You have studied this earlier as well. All I can say is understand it with a thought that I have studied it, but I don't know the nitties and gritties of it. Fine. So are you guys ready to check on this histogram? Tell me in the chat section. Fine. So let's go ahead. So if I write its technical definition, everybody, you do one thing, take a register, take a pen, start writing its definition, fine. Basic definition, it is a graphical representation of spread of data, fine. Primarily here when we talk about data, it is generally numerical data, fine. Fine, is that clear? Now, in this case, let's take an example. Let's take a small example, and for the first time today, you will understand why exactly histograms are very useful in the field of data science. They will tell you, fine. Now, I'll go ahead, I'll take an example of, let's take here itself, fine. So, example is IPL. IPL is going on right now. Everybody is watching IPL. Say you have a data set where runs of batsmen of a particular team are stored, fine. So, somebody has scored 10 runs, somebody has scored 20, somebody has scored 40, somebody has scored 30, fine, and somebody has scored 60, and then what, 1, 2, 3, 4, 5, somebody has scored 5, then 10 again, then 9, and what else? 1, 2, 3, 4, 5, 6, 7, 8. Fine. So we have 8 outputs. We need 3 more. So I'll remove this brace and I'll write 3 more. So I'll then have 4 runs, then have 2 runs, and then I have 100 runs. Fine. So somebody has scored 100. Now in this case, if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 outputs. Fine. 11 people generally play in a cricket team. So you don't like IPL, fine. If you don't like IPL, then in this case, consider them the marks of a class. Fine. People have scored these marks. Consider it, whatever you like. These are mere numbers. याद रखना, numbers हैं. इनके साथ जैसे खेलना चाहो खेलो, ठीक है? So here, out of these numbers, if I talk about these numbers, then for me right now, these are runs for an IPL team. So anybody who is not liking the IPL, then for you, these are marks. Fine. Now understand a fact. Here, one value is 100. Fine. One value is 60. Others are very less. So we'll try computing the sum of all these. And me being a perfect engineer, like always, I'll switch to the calculator. And all of you who have been keen students of engineering, they know that we engineers never use our brains, we use calculators. Fine. So I'll go ahead and I'll explain you that how exactly this calculation is taking place here. Fine. So 290 is the sum. Fine. We are trying to take out the mean. 290 is the sum. I divide it by 11. Fine. You have 26.3636. Now if you carefully see, the average runs scored by each person are 26.3636. This average doesn't seem to fit well or doesn't seem to give a clear idea of this kind of distribution, isn't it? This is not giving a very good idea because somebody has scored 100, somebody has scored 60. I don't know what exactly is a good value to take measure of in this data set. So what I'll do is, I'll go ahead, I'll take one example of histograms. Fine. And this histograms example is very, very important because now I'll show you how exactly this helps. Fine. So let's create some ranges. 0 to 10 is one range. 10, not exactly 10, I can name it 11 to 20 to be precise. 11 to 20, then 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90 and 91 to 100. Fine. Now when I talk about 0 to 10, how many people have scored in this range? 1. Fine. This is, let's change the color of the ink. 1, 2, 3, 4, 5 and 6. So 6 people have scored in this range. Fine. So I'll write here 6. Fine. Then for 11 to 20, there is one person. Nobody else is there. So there is 1. Then for 21 to 30, there is one value. See, 30 is there, na? Then similarly for 31 to 40, there is one value. 40 is there, isn't it? And now you have 60. So 60 lies in this range, 51 to 60. And then you have 100, which lies in this range. Rest all are 0. Fine, there is no value of these. Now if you carefully see this data, what we'll do is we'll plot this like this. Fine. So this is origin and I should come here so that you clearly see this. Fine. So I'll mark a few things and then 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90 and 90 to 100 basically. Fine. So in this case, when we are trying to figure out, in this case, what we can do is, I'll take some different ink for here, and 1, 2, 3, 4, 5, and let's say 6 is here. Fine, I'll make it differently. Wait for a while, have a patience, and you'll understand everything here. Fine, whatever I'm writing. Now first of all, carefully see. These partitions that I have created are called bins. Fine, these are called bins. Further, when you will study data science, this would come handy to you. Fine, so these are called bins, these partitions. These values that you're getting here are plotted on y-axis, this is on x-axis. These bins will be on x-axis. Fine, so what I'll do is, and these are not continuous, so what I'll do is I'll take this orange color. Fine, so for 0 to 10 you have 6, so you have to create like this and create a structure like this. Fine, not exactly like this. I'll take it from 10 and with a better color. This is not as dark as I want it to be, so this suits well. Fine, and let's take it from here. So yes, this particular one block, fine, this block represents this particular domain or this bin where you have it is telling you have 6 such batsmen, fine, who have scored between 0 to 10. Here you can write like this, batsmen. Fine, so you have 6 such batsmen who have scored in this range. Now when I talk about 11, fine, when I talk about 11 to 20, in this range one batsman has scored. So from 11, somewhere 11 would start here, 11 to 20 would be here. Fine, one batsman has scored. Now if I tell you that from 21 to 30 same haal hai, fine, so this was 20, say 21 to 30 is this. Fine, there is a small gap between them and I want to show you that gap. Henceforth I'll do a few things for it. So 20 lies here, and in this case we'll have like this. Okay, so 21, consider 21 is here, and 21 to 30 again there is one particular person who has scored between this. From 31 to 40 same lies there. Fine, so from 31 I'll draw it carefully, and from 31 to 40 again there is one person who has scored, and then you have absolute zeros. For 41 to 50, for 51 to 60 you have one person who has scored, so 51 to 60. Fine, this is 51 to 60. Fine, so one person has scored between 51 to 60, one in 31 to 40, one in 21 to 30, one in 11 to 20, and 6 people are there who have scored between 0 to 10. Now there is one more person who has scored between 91 to 100, and for him I am making this here. Fine, there is one more person who has scored it here. Now if you carefully see, in this case two things you can conclude. First of all, most of the people have scored in this area 0 to 10. Fine, so taking an average which tells you about 26.3636 is of no use. Now you realize why this is so important. This is a part of descriptive statistics only. ये भी descriptive statistics ही है. Fine, this is descriptive stats only. But here in this particular descriptive stats, what is important to know is that we were scoring or we were giving our mean somewhere here. Fine, somewhere in this range. But actually most of the people have scored between this range 0 to 10, isn't it? Also, why is this range going up? Why the value of this mean is going up? Why did it go up? Because of this culprit. Fine, this particular culprit who is an outlier. Due to this the whole average shot up. Now is it clear? This is histogram. These building blocks are histograms. Is it clear now? Tell me. Tell me in the chat section. I am seeing it. Tell me in the chat section if you guys can see it. Fine. Is it clear to you? Yes or no karo fatavat. If it is clear, drop a yes. If it is not clear, ask your doubts. I am here to explain it. Fine. But remember, this particular culprit is an outlier. इसके कारण पूरी average खराब हो गई. ठीक है? Great. Sumant, is it clear? Cool. Cool. Thank you, Sumant. Fine. So now, in this particular scenario, how exactly this can help? This can tell you, first of all, that this is the outlier, one thing. Second, what it can help you is, it can let you filter out segments of low scoring and high scoring. Fine. You can create a segment here that these are low scoring batsmen, these are high scoring batsmen, and then you realize most of the team is on the low scoring portion. Fine. Such segmentations can be done. Such segmentations can be done. When you try figuring out some credit risk for any bank, imagine a situation where a bank is trying to figure out to what customers they can give loans and what is the risk of giving the loan. At that point of time, they can see how many people are in old age, how many are in age of 40 to 50, how many are age 60 to 80, and then they can put various filters. They can divide them into useful bins, these bins. Fine. Where they can tell that this particular person who is of 60 to 80, this range is of old age people, not very comfortable for giving loan, because if we give them loan, they'll first of all not accept, number one. Secondly, the chances of repayment are less. For the people who are very young, they also might falter. For the age of 30 to 50, this is a very good loan giving bracket. They can figure that out, and this is why histograms are important. Fine. Now there are various other things which is smoothing of histogram and probability distribution functions. So we'll study them in the subsequent classes when we'll study about probability. But for now, this is the basic of data science statistics where histograms are used. I hope this much is clear. If there is any doubt, go ahead, ask it out. वरना यहाँ पे आज wrap up करते हैं. It was an easy thing, but it is important to understand what exactly is histograms. Fine. Is it clear to everybody? I don't want to keep these sessions long and boring so that you guys enjoy statistics. I don't want you to hate statistics because most of the people do it. Fine. So I want you to love statistics, and for that, small details, small sessions can be helpful. Go ahead. Tell me, did you enjoy today? Was it good? Is there any doubt? If no, we can wrap it up. As simple as that. I'm waiting for a minute. Tell me, and then we can wrap this up. So no doubts? Now if you want this PPT, in any case, if you want this PPT, all you need to do is join my Telegram community. Fine. If you join my, great. Okay, Sumant, then we'll wrap this up. But if you want this PPT as notes, you can join my Telegram community. In that, I'll float this as the notes for today's class. And as I always say, keep doing good. Fine. For others, good will come back to you. Fine. Bina soche kuch, you keep on doing good things, and good things will come back to you. So you're saying that you will tell something about the gap between the bars. Okay. This gap is basically the discontinuity. Look, these are not continuous graphs. Histograms represent these bins, and if you correctly see, these bins that you're seeing here are not continuous. This is 0 to 10, then 11 to 20. Fine. So from 10 to 20, I'm not starting it. That is why this is a gap, because this value that I'm taking, I'm considering it 11. This I'm considering 21. This I'm considering 31. This I'm considering 51. This is being considered as 91. Fine. So these values that you're seeing here are the representation of these values only. Fine. So fine. I hope that is clear. And henceforth, I'll wrap this up. Have a wonderful day ahead, everybody, and spread the knowledge as far as you can. Even if you don't share the video, you go ahead, spread your knowledge, spread your wisdom as far as you can. Fine, and subscribe to this channel if you want more such interesting videos. Have a wonderful day ahead. Bye-bye.